Today we are going to look at virtual private cloud, that is Amazon Virtual Private Cloud, or VPC as it is called more commonly. VPC allows you to secure your cloud with a private infrastructure network, and we are going to see what are the different components that makes up the VPCs, how to set up a custom VPC, and what are the different configurations that are available to us to secure our VPC. So before going forward, I'm going to assume that everybody knows what is an IP address and what are the different IP addresses available, or what is the private IP address, what is a public IP address. If not, I would strongly recommend and go ahead and familiar yourself with the Wikipedia article. There is a fantastic Wikipedia article on private IP addresses, what are the series of IPs that are available for private, and what are the series of available IPs for public. There are three subnets basically. You should go ahead and read them because it is very much relevant here, because Amazon uses a 172 series for the default VPCs they create, and when we are creating VPCs we are going to use the 10 dot series IP addresses. So that is kind of a prerequisite for understanding some of the things that we are going to discuss here. So briefly, the agenda is as usual. What is a VPC, how to create a custom VPC, what are the common use cases, and we'll finally have a demo to show and tell how to create a custom VPC. So diving deep inside VPCs, VPC forms a part of the networking services, networking foundation services that Amazon offers, and of the four that you see here, we are today going to focus predominantly on the VPC group of services. After this, we will see the elastic load balancer and the Route 53 and finally the direct connect options. So let us go ahead and see what are the components that make up an VPC. So typically when you're trying to set up an VPC, all of these components, or at least most of these components, come into play, especially the subnet, the routing table, the elastic network interface that is on the left hand side, right hand side of the imagery, and network ACL. All of these things come into play. But if you're going to set up a private hosted zone, or if you're having your own domain name, or if you're trying to connect to your VPC through the internet, then these two services come into play, as well as a VPN gateway. So depending upon whether you're going to come from the internet or have all the network connectivity locally, then you're going to have, depending upon those use cases, you're going to use the different components. So I'm going to show you how to set up a simple custom VPC in your account by using some of these components here, so that we can secure it by using our security group, we can secure it using our network ACLs, and then what is exactly high availability impacts here. When you're choosing highly available two availability zones, how do I ensure my subnets are spreading across two availability zones? We will look at all those components slowly now. So just a brief definition: when it says VPC, always think of it as a logically isolated area, and they share a common security and interconnections. So always remember this: almost everything in Amazon is logical. There is everything is virtual. Unless you buy a dedicated host or a dedicated machine, everything that you buy in Amazon is logical. So here also, when you are creating a VPC, a virtual network within AWS Cloud, that is a logically isolated area. In other words, your VPC cannot communicate to your, if you have two VPCs, they cannot communicate to each other by default. And your customer or you are having two VPCs, both of them cannot communicate to each other by default. They are isolated, and you need to enable the connections between them. And the security is, if you set up some security rules within your VPC, it is applicable to all the components that is inside your VPC. You might have a load balancer inside your VPC, you might have an EC2 instance, you might have an RDS, that is database instance, or a web server, application server, any type of server that you might have running inside your VPC. The security that you configure in your security group will be applicable for all of the VPCs. If you want to apply it for a smaller subset of areas, then you apply something called network ACLs, that is network access control list. So depending upon the type of security you want, you have two different options. If you want all of your VPC resources to be affected by the security control, then you use a security group. If you want it only to a particular subnet, then you use a network ACLs. There is another information slide which will explain to you a little bit more on that further in, down the line. Let us look ahead and create our first VPC. So when we are talking about VPCs, we are going to talk about the CIDR, that is the choice of range of IPs that we are going to use. So when I say 10.81.0.0/16, it gives you a maximum of 64,000 IP addresses. You should be able to understand what is a /16, what is a /24, what is a /25. These are all typical mathematics. It is raised to the power of 2. I mean, it is a 32-bit IP addresses we are talking about, so you should be able to calculate it. And refer to the Wikipedia if you are not familiar of calculating IP address ranges. So when I say /16, it gives you, as you can see in the bottom, there are 64,000 IP addresses. When you say /24, you get close to 251 IP addresses. Actually, when this number will calculate to 255, but Amazon uses 4 IP addresses for their internal purposes. That is for internal VPC routing, internal growth, and for future growth as well. So any range that you choose, 4 IP addresses will be reserved by Amazon for its own purposes, and you will get only the remaining IP addresses. And the maximum and minimum is given at the bottom of your screen. You cannot create anything lesser than this series, that is /24, and you cannot create anything more than that. So in other words, if you create a VPC, you cannot have more than 64,000 resources sitting inside one VPC. You need to create another VPC. So your choice of CIDR, or as you see here, the range that you choose will decide how many resources you can put inside a CIDR range. So by default, the Amazon default VPCs will have /16, but if you're going to customize it for your customers, then you need to decide what is the CIDR range is going to be, whether I'm going to use /17, /18, and what is the difference, and how many IPs that I will get inside them, or some things that you need to decide with your customer and the type of resources you are going to run inside. So let us, for example, in our use case, assume that we have created a VPC with this CIDR range. So you have an entire VPC here with 65,000 IP addresses. Now we need to split it into multiple small subnets for each availability zones. So let us take one availability zone for our example, on that is going to be on the left hand side, and I'm going to create a small subnet. A subnet is nothing but a small subset of IP addresses. So out of the 65,000, I'm going to take 255 and I'm going to create a public subnet. So as you can see here, this is 10.81.1.0.0/24. So this will give me 255 IP addresses, or in other words, I can put 255 resources inside my public subnet. So assuming if I want a private subnet, when I say public, the resources inside this subnet are going to have internet access, or I'm going to provision them internet access. It is not by default they will have internet access. I'm going to provision internet access to subnet or resources inside this subnet. So say for example, I want some database servers which I don't want to have public internet access inside the same availability zone. So what I do is I go ahead and create a private subnet, and that IP address range is going to be 10.81.2.0/24. So I have two subnets in my same availability zone, all part of the bigger VPC that you see here. So these subnets, both of them will sit inside this VPC. Everything is part of this VPC, so they can talk to each other. But since I have decided my web servers are going to be public facing, I have grouped them separately, and there will be a separate security group I will create for them, and there is a separate security group I will have to create for them, and I'll give internet access because it is public facing. And since this is private, or my databases are going to reside here, I will not give any internet access to that. For now, all you need to know is subnets means a subset of IP addresses which is coming from the bigger VPC group. and you can name them in any particular way that you want. I have named them public and private so that we can easily understand what their purpose is. You can have another subnet only for elastic load balancers here, or you can have another subnet only for S3 buckets. All those things are possible. It is absolutely flexible, configurable, and you choose how you want to do that. So now that we have created multiple subnets in one availability zone, what if we need one more availability zone? So what you do is you go ahead and create similar structures so that it is very easy to maintain and understand. And you can see here the IP address range is continuing quite uniformly. So my odd number series, that is when the third octet is odd numbers 1 and 3 here, I know that it is going to be public subnet. When it is going to be an even number series, that is 2.0 here and 4.0 here, it is going to be a private subnet. So that way you need to have some logical organization so that it is easy to understand. By looking at the IP address itself, you can say that this IP address is from a private subnet of my availability of my VPC, and this IP address is from my public subnet of my VPCs. And if it is from one series, I will know that it is from availability zone 1A, and if it is from 3 series, I will know that it is from an availability zone 1B or 1C, wherever you are starting. So it is very easy to understand your infrastructure when you have a common subnets, or if your subnets have a logical structure to it. So now that we have created a VPC, we have created subnets in 2 availability zones. Now we need to set up one connectivity for them. Especially we are talking about internet connectivity. So what we do is we go ahead and create an internet gateway as shown here. The internet gateway sits at the boundary of your VPC. It is a logical, don't imagine physically, it's logical. Why I put it in the boundary is any traffic that is going to go out of the VPC to the internet is going to pass through this gateway. So we create an internet gateway and then we attach it to the VPC. So that is what it means here. And finally, for all the traffic to flow through, Amazon will internally provision an VPC router so that all the traffic from your subnets will be flowing through your VPC router. So your private can also talk to your public, and then your public can crisscross all the way to the other availability zone also, because this router is inside your VPC and all traffic within your VPC is not restricted by default. So every traffic inside your VPC happens by default, but if it has to go outside your VPC, that is when you need to configure tools like internet gateway or pairing with another VPC and all those kind of things. For now, we will talk about connections between the same VPC and connections going out to the internet. So your VPC router will have a routing table. The next we will see is routing table that you can see here. The internet traffic will be sent here, that is 0.0.0 will be sent to the internet gateway, and from the internet gateway it goes all the way to the internet itself. So now we have set up our VPC and we need to secure it. For security, the service name is security group itself, and as the definition on the left hand side says, security group acts as a virtual firewall and it is also stateful, meaning when an incoming connection comes with a particular port saying that it wants to reach port 80 of my public subnet, so the return traffic will also be sent to the same IP address where the request comes from. So in other words, the firewall knows that what is the incoming IP address, what is the destination IP address, what is the incoming port, and what is the outgoing port, and remembers all that information when the traffic is going out. So that is called a stateful firewall. And in a stateful firewall, it is applicable to the whole of the VPCs that you create. And you can have any number of security groups you want. For example, if you create a web security group and then you can put all your web servers inside that security group, and logically it sits inside your sits atop your public subnet, and you can open your port 80, port 8080 and all those things in your web security group. And you can logically create one more security group also to have more security for your databases, called database security group, like as shown here. And it will logically sit on top of your private subnets so that any databases can take the security group and allow only connections on certain ports. For example, Oracle runs on 1521 and MySQL, if I'm not wrong, it is 1433. So you can open only those ports for those security groups. And you can also restrict your database security access further by saying my database can be accessed only by my web security group, not directly from the internet. So that is also possible. So that way your database security group ensures that nobody else talks to the databases directly except the application servers or the web servers if necessary, and any internet bound traffic is blocked by default for my database security group. So this is how you set up a DB security group. And likewise, if you remember, we can set up another subnet for elastic load balancer, and you can create another security group for load balancers, or you can create multiple security groups. Say, for example, for Oracle, one security group, for MySQL, another security group. All those kind of things are possible because it is configurable, and you can define as many security groups as possible. There are limits, but most probably for the most default configurations or most medium level configurations, you will not hit the limits of the security groups. And for each security group, you have tons of rules available. Close to 50 inbound, 50 outbound rules are available, and we should be able to ensure the security inside our VPC within those rule numbers. We don't have to hit the limit. So it's a logical way of looking at your security groups here. Say, for example, you have an EC2 which is in a web tier. So what you do is you open your port 80 and 443 traffic, and then what happens is when your port and 80 and 443 traffic is open, only that traffic is allowed to that web tier. Whereas you have a bastion host or jump server or anything that you might be familiar with your production infrastructure, it is to connect to other servers. That is usually for bastion host port 22 and port 3389 for RDP is open. From this port, you will be able to access only this EC2 server, not others directly. So it will be from once you log into this server, you can connect to this server, you can connect to this server. And then you can enable a VPN connection also is possible. So your security group by default will allow that VPN access also, so that you can connect your database tier to sync your database connections and on premises. Any other traffic apart from that is configured here will be blocked as it is shown here. So rest of the traffic will flow through, but your traffic that is not configured by default will be blocked by your security group, and it will be bounced off. You can configure some kind of monitoring like flow logs, and you can monitor the logs to see what are all the rejected packets, who are all the incoming IP addresses at those rejected packets, and do some analysis over it. This is just a logical structure to understand how a security group works. So when I say security group, this is a couple of screenshots are there to show you how a security group is configured. Here is an example of say I want to enable port 80 access for the incoming traffic. So what I do is I go ahead and choose the type as HTTP and the protocol as TCP, and the port range is 80. And 80 is not necessarily have to be default. If you configure your web server to run on 8080 or 8000, you can go ahead and choose the same IP, so same port number of your web server, and then the incoming traffic, or that is the source traffic, is going to be the entire internet, that is 0.0.0/0. So that is for your web security group. Moving forward, we look at the database security group. Here it is a random port number that is given 2345. If you want, you can configure your backend or your database into a different port number instead of the default one, and give your port number here. And you can see here it is given a particular security group, that is SGS82 blah blah blah. If you go ahead here, if I bring your notice to here, you can see here my SGA2 is related to my web servers. So in other words, only my web servers can send traffic to my backend servers. So what it means is my database is secured even more, not only on the port level, but the incoming traffic is also secured by saying only allow traffic from my web servers, not from the world. So this way it is even more tightened, and unnecessary traffic is stopped at the web server level itself. So network ACLs, this is another security group, another security mechanism that is available in your VPC. These are all stateless firewalls. When I say stateless, they don't remember the incoming. Once they allow the incoming IP to the destination IP, you need to configure manually the outgoing rules also, because they don't remember the outbound IP address or outbound port numbers. So you need to configure the outbound rules as well, not just the inbound rules. That is what network ACLs are meaning as stateless. They don't manage the state when they are incoming. So once they pass the traffic into your VPCs, they forget all about the connection. So the return traffic, you need to set a rule saying if it is outbound traffic, internet traffic, allow them or deny them, or if it is outbound traffic for this particular IP address or this protocol, so deny everything. So that is the difference between your security group and your network ACLs, where a security group is stateful. They remember where is the incoming, where is the outgoing, what is the port number they came and what is the destination port they are going out. Whereas when you come to network ACLs, they don't remember that. You need to configure both inbound and outbound rules. So since it is having a stateless situation, you need to configure your rules based on rule numbers. So the topmost rule takes priority. Here it is 100, and this rule takes priority. If your rule is allow and you will go ahead and deny at the bottom, say for example, as you can see here, the next rule or star means any traffic that is not matching the previous rule, this star will take care of that traffic. So any rule that is not matched in the first rule or a previous rule will go ahead and follow this rule. And if the rule is going to deny it, then it will be denied. But here we are allowing all the traffic and later we are denying it. So that is not a problem, because the first rule takes precedence. And always remember that if you want to deny something and then you go ahead and allow it later down the line, it won't work. So allow whatever you want to allow, that is particularly port 80 or port 443 or anything, allow it, and deny all other traffic. So that is how it should be configured. So that is the network ACLs part of VPCs. Let us move forward. And interesting thing about network ACLs is they are applied at a subnet level. So if you have a private subnet, if you have a public subnet, if you have a DB subnet, if you have a web subnet, you can choose where your network ACLs are to be applied. They are not applicable to the whole VPC itself. You choose which subnet they want to be associated with, so that the impact of that security that is given in the network ACLs are applicable to only the subnets that you have chose them with. So you can allocate them to one of them or all of them or everything in your account also. It is also possible. It is fully customizable. So this one allows all traffic in. And then finally the routing table part of it that we are going to look at now. So your VPC has a default routing table. When you create a custom VPC, your VPC contains the default routing table, and the default routing table will say allow all internal traffic. That is, as you can see here, that is the local traffic, everything within the same VPC. This is the default VPC that Amazon has created, and anything inside the traffic will be locally targeted inside only. Don't go outside. So if you have to go outside, then you need to configure your rules. For example, let us talk about sending your traffic to the internet. Then what you do is you create an internet gateway using the internet gateway option that is available on your VPC dashboard. You create it and attach it to your VPC. So, and then once you attach it, then you automatically the routing table will also have to be updated by saying internet bound traffic, that is 000, has to be sent to my internet gateway, and from my internet gateway it will automatically flow out to the internet. And there are two more things when we are talking about VPCs that is important and relevant that we need to remember. That is the DNS resolution and DNS host names. So if we want our resources to have that nice little IP address .awsamazon.com fully qualified host names, then we need to enable the DNS host names in our VPC. And if we want to not only create those host names, but you also want them to resolve those host names, then you need to use the Amazon DNS server. So you need to turn this setting also into yes status. Usually by default it will be no. You need to enable it. Don't worry, we will be seeing all of those things in demo shortly. So it is just to understand that you are not setting up the DNS server itself. It is just a setting in the VPC. It will be whether enable or disable. You're just going to have click on enable if you want to use the DNS resolution. So if you have two servers and ping each other server using the host names, they will be resolvable using those host names if you enable this option. If you disable it, they won't work. We can test that as well. This is private hosted zones. For now, we will ignore it. When we are looking at Route 53 in depth, we will look at how to create a private hosted zones in VPC. If you have a, say for example, if you have abc.com and if you have not registered abc.com, if you want to register servers which are routable with abc.com, then you go ahead and use a private hosted zone. In other words, it's a private DNS which is applicable only within your VPC. The outside world will not be able to see here. You can give any name here because the traffic is going to be all internal to your VPC. The outside world will not know about it. So you can go ahead and create anything you want here. For now, we'll just skip this one because we will see in depth of how to set this one and how to test this private hosted zone in our Route 53 demo classes. So this is the entire logical structure of your VPC. So you can see here there are two availability zones and there are two resources, and at the and you have the security group that is available for the entire availability zone in A, whereas you have multiple security groups you can configure that is customizable, as you can see here. Then you can isolate your traffic based on network functions. For example, that 0./24, which gives you 255 IP addresses for, say, web servers, whereas 1.0 is for application servers or some other batch management servers. And then you have a network security group available for that network ACL or for particularly that particular subnets. And then you can route your traffic also. If you want internet based traffic, you can allow it to send it to the internet, or if it is an internal traffic, you can send it locally itself. So based on the traffic shaping that you want to do, you use your routing table appropriately. And then there is an internet gateway and VPN gateway. VPN gateway is mostly for connecting your on-premise and your cloud. We will look at the VPN gateway or NAT gateway when you're trying to set up a NAT gateway. For now, just remember that VPN gateway or NAT gateway that you see in most logical diagrams of VPC is to connect your on-premises or connect securely to your VPC through a IPsec tunnel or a VPN tunnel. That is where a VPN gateway comes into picture. So that is it for VPCs. We are that is about for the components that are involved in a VPC, and we are going to set up a demo to configure it, and then we'll try to connect to our VPCs now.